గుడ్ మార్నింగ్ స్టూడెంట్స్. సో ఈరోజు షెల్ థియరీలోని లాస్ట్ ఎగ్జాంపుల్ మనం క్లాస్లో చెప్పిన వాటిలో లాస్ట్ ఎగ్జాంపుల్ని డిస్కస్ చేయబోతున్నాం. సో హియర్ దే ఆర్ గివింగ్ టూ కాన్సెంట్రిక్ స్పియర్స్ and the total charge on the two spheres is given as total charge is given as capital Q, and let small r and capital R be the radii of spheres. Okay, and next they are giving that each both spheres are having the same charge density. Here the charge density is considered as a surface charge density. రెండిటికి కనుక సర్ఫేస్ చార్జ్ డెన్సిటీ ఒకటే ఉంటే దెన్ వాట్ ఈజ్ ద కామన్ పొటెన్షియల్ అన్నది అడుగుతున్నారు. కామన్ పొటెన్షియల్ ఎంత ఉంది అని చెప్పేసి. సో దానికోసం నేను ఏం చేస్తున్నానంటే ఇన్నర్ స్పియర్ మీద ఉన్న ఛార్జ్ Q1 అని, అవుటర్ స్పియర్ మీద ఉన్న ఛార్జ్ని Q2 అని అనుకుంటున్నాను. సో యాజ్ ద గివెన్ టోటల్ ఛార్జ్ ఈజ్ క్యాపిటల్ Q కాబట్టి, సో గివెన్ దట్ capital Q is equals to Q1 plus Q2. This is my first assumption. సో ఇప్పుడు వెంటనే ఏం చేస్తానంటే let it be therefore potential at inner sphere due to the charge Q1 at a distance of small r V1 is equals to 1 by 4 pi epsilon naught Q1 by R plus 1 by 4 pi epsilon naught Q2 by capital R. This is the first observation I got. So the common potential is V1 here. So common potential calculate చేయడానికి మనకి కావాల్సిన ఇన్ఫర్మేషన్లో Q1 Q2 ఎంత అన్నది తెలియదు, రైట్? సో లెట్ ఇట్ బి దిస్ ఈజ్ ఈక్వేషన్ 2 అనుకుందాం. సో ఇంకొకటి ఏమి ఇచ్చారు, both are having the same surface charge density, which means so I can say sigma of the small sphere is equals to sigma of the big sphere. Here I am taking the small sphere and big sphere, which implies Q1 by 4 pi r square is equals to Q2 by 4 pi capital R square. That is the meaning here, isn't it? So charge upon surface area, charge upon surface area. So the inner sphere has the Q1 charge and the outer sphere has the charge Q2. Inner sphere radius is smaller, outer sphere radius is capital R. So by getting 4 pi and 4 pi cancel, I have the relation such as Q1 by Q2 is equals to small r square by capital R square. So by adding 1 on both sides, Q1 by Q2 plus 1 is equals to small r square by capital R square plus 1. So by simple mathematics, I can say Q1 plus Q2 by Q2 is equals to R square plus capital R square by capital R square. So this implies since Q1 plus Q2 is the total charge, capital Q by Q2 is equals to R square plus capital R square by capital R square. From this, I can say Q2 is equals to QR square by R square plus capital R square. Now I got the value of Q2. Similarly, I can say Q1 is equals to capital Q small r square by R square plus capital R square. So since I got the values of Q1 and Q2, I can substitute in the equation second and I will get the relation, I will get the value of V here. So therefore put 3 and 4 in equation 2, we get V is equals to V or V1 is equals to So the equation I'm writing here, V is equal to KQ1 by small r. But what is Q1? This is the one. So QR square by r square plus a small r square plus K by capital R into Q capital R square by r square plus a small r square. So by eliminating the r and r here and capital R here, so I can rewrite this one as capital Q K small r by capital R square plus small r square plus capital Q capital K capital R by r square plus r square. So by getting common factors, I can write this one as KQ by capital R square plus small square into capital R plus small r. So this is the expression for common potential. So I think you get what is there. Okay.